Hi everybody. Okay, welcome to week 3 lecture 2 arrays. So I've just got a few announcements before we start, like with content. So on the 9th of October by 11:59 p.m. Actually, I hope everyone can hear me. Yes, and see me, whatever. By the 9th of October 2025, 11:59 p.m. That's the last day to drop any of your courses without financial liability or academic penalty. So that's called the Census date. I just wanted to let everybody know this is for all your courses, not just this course, in case anyone's in that position. You can get more information from that link. Okay. I hope you've all sort of heard about the fact that we've got the public holiday on Monday. On the forum, there's a post where you can book in for a different tute lab just for that week if you're a Monday student. Well, if your tute and lab is on a Monday. I'll be posting a recording for the lecture to make up for Monday. By Monday at the latest. I'll hopefully have it up before then. We'll see how we go. And then because of the public holiday, we're changing to due dates for the labs. So lab 3 and lab 4 will both be due on the Tuesday instead of the Monday, right? So it's just for those 2 weeks, then we're going back to the normal schedule. The other thing is, I don't think I've said this before, assignment 1 will be released early next week. So probably Tuesday night, but we'll see. It won't be released on the public holiday though. Okay, one more thing. We've got some revision sessions starting in week 4. These are different to help sessions. These are more structured. It'll be a bit like a mixture between a tutorial and a lab, where you'll have a tutor talking through things, but also you've got and explaining things, but also you'll have some revision style, basically lab style questions to work through as well and get help with. And of course, they're not worth any marks. It's just for revision. So look out again. There should be a forum post coming out soon with information about how you can attend these sessions and when they're on. Okay. All right. So yeah, we've always got a link to the live lecture code. And as usual, here's the link. My disclaimer, because we're going to be talking a lot about style today, my disclaimer is sometimes in the live lecture code, I'm sort of typing in things to answer questions and I haven't gone and cleaned it up and polished it perfectly. And sometimes I've got extra comments that are explaining things that, you know, in real comments you wouldn't write. Like, this is a return value, or, you know, something like that, that's explaining stuff to you, which you wouldn't do with code usually. You expect that the person know how C works, but you're explaining, you know, what you're doing rather than how C works. So that's my disclaimer. All right. So what did we do yesterday? Gosh, it was only yesterday. We did a bit of a recap of nested while loops, structs, and enums, and then we started functions. And today we're going to do a little bit of a function recap. We're also going to talk about just a few finer details about functions that we didn't get into. We'll talk a bit more about style in general. I'll show you some handy tips for a few shorthand code things. And then we'll talk about arrays, which is a really important topic. So arrays are very useful. Plus, they're one of the 2 topics that's a hurdle in the final exam. So it's very important. Don't stress, you're going to have lots of time to get on top of arrays, and you'll have lots of labs. You'll have an assignment that focuses on arrays. So you've got lots of opportunities to get on top of them before the end of the term. Okay, so let's do just a bit of a functions recap. So does everyone remember is there any, oh, well, sorry, I'm distracted by the chat. Do we all remember what functions are for? So the first thing is a function is an independent reusable block of code that performs a specific task. So that's the point of using them in computing. Now, I went through this example yesterday. I'm going to go to the code. Now, don't worry about every single detail of this code, but I just want to really show you the benefits of functions through this sort of example. Now, on the left-hand side, we've got the code. You know, we've got a Pokemon enum, a Pokemon struct. We made a struct, we gave it some data, and then we, you know, tried to print it out. And we ended up having to do this really long if statement to print out the enum, like so whether the Pokemon's a fire type or a water type or an ice type, etc. But then our Pokemon had two types. So then we had to copy and paste it and change it a bit, right? And this was just for one Pokemon. If we had more than one Pokemon, would we have to go and copy and paste all this again to print out the next Pokemon's details? That would be really repetitive and error prone. And we noticed to do this, like we've got this really, really long main function. So style-wise, that's not good. So what we did was we created some functions. So does everyone remember what void is? What's void? A void return type. I'll just give you, yeah, it doesn't return a value. Yep. So these two functions we wrote, they either took in an enum Pokemon type or a struct Pokemon type, and they just printed things out on the screen. They didn't actually return anything back to the code to use. So we wrote them. We don't need to go through all the fine details of the code now, but we've got them down here, and they're prototypes at the top. And in the main, we were able to just call this function print Pokemon. So if you look on the left, our main started here and went all the way down to here. And on the right, we've got this nice, much smaller main. I mean, could we put this in a function? Yeah, probably. But anyway, we can't do everything in the lectures. So we've just got this nice thing. It's much easier to read. We just see, okay, we've got some Pokemon, we're setting its values, and now we're printing it out. Okay, we don't have to scroll through all of this to see what on earth is happening in this main function. And it also, so it's much easier to read. We can go and look at these other functions, you know, if we're interested in those, but we don't have to be overwhelmed by everything at once. We've got a lot less repetition, right? We only had to write this once. And any time in future when we want to print one of these types, we just call this function. Okay, so these are the benefits. We can break it down into pieces, we can reuse things, and abstraction. We can just look at the main at a high level without seeing all the details. And it also allows us to test our functions. We didn't do this, but we could go and really test those functions, you know, and then once we're using them, hopefully they're not going to be a source of error in our program. Okay, so hopefully you're sold on the benefits of functions. Okay, now here's just another, this function is very simple. Do we really need a function to add two numbers together? Not really, but it's a very simple example so we can see how things work. Up the top, we've got our prototype. We've got the name of the function, which is called add numbers. Add numbers is going to take two inputs, two double inputs, and it's going to return a double input. Okay, And in the main, we're using this add numbers function. So let's just go to the code and I'll just remind you of how it works. I'll get rid of this. Okay. Now, can everyone look at this and try and work out what this program's going to do first? By reading it, but let's go through it in sort of more detail. So I spoke about this the other day, but I want to just speak about it again. When we've got multiple functions in our program, well, we always start with the main function, but each function has its own little spot in memory where it's got, you know, a chunk to store its own variables. So the main will have a spot in RAM with its variables, and it's got one called x, and the value of x is 9. It's got another variable called answer, and to start with, that doesn't have any value in it. It's uninitialized. And so right now the main function is running, but it's doing a function call. It's saying I want to call the add numbers function, and it's passing in values. So it's passing in 1.5 and whatever the value in x is. So x has a 9 in it, it's passing in a 9. So we stop executing the code in main and we start executing the code in add numbers. Now, what data does add numbers have? Well, it's got these two things here. These are the inputs. We call them parameters. So we've got x, and that just gets the first value that was passed in. So the x will get 1.5, and the y is getting a 9. And this function also has a variable called sum. So these are all the variables, right? The ones that are in main and the ones that are in add numbers. And as we can see, and I did say this yesterday, but I just want to really stress it, we've got a variable called x, or a parameter called x in add numbers. This is not the same x that's in main. They just happen to have the same name. In this example, they don't even have the same type, right? They're not the same variable. So hopefully everyone is happy with that. Now, inside this function, what's happening? Well, we're just saying sum equals x plus y. So sum's going to be 1.5 plus 9, and we're going to get 10.5. Then this really important line of code at the end is saying return this value that's in this variable. So this return has to return a double. So the value that's in sum is 10.5. So it's returning that value 10.5 to the main. And the main is storing that in its variable called answer. Okay, so this is what's actually happening. And I can see a few questions down there. Now, when this function has finished, it's done it's taken its input, it's done some calculation, it's returned its value. This memory can be used for something else, right? The function's not running anymore, it's finished. That memory gets, you know, gets reused by something else. Those values are sort of gone. And then we end up with the answer is and also after the function call, we continue executing wherever we were up to in the main. Like whatever the next line is, it just keeps executing. So it'll print out the answer is 10.5. And a few people are asking about, does it matter if it's integers or double? Well, the thing is, if I've got if I've got a variable of type double, can it store 9? Yes. So it's okay to put integers in doubles, right? But if I've got a variable called x, well, it doesn't matter what it's called, but if I've got an int variable, can I put 9.5 in it? No. Okay, so generally speaking, it's not a problem to go and try and store the value 9 in a double, but it would be a problem to try and store, 9.5 in an integer. Okay. All right. So yeah, I made sure there were two x's here just so people could see that they were two completely different values. All right. So that's how the functions work. Hopefully that kind of makes sense. All right, now the next thing I wanted to talk about is the difference between local and global variables. So in C, we've got these open and closed curly brackets, and the code inside that we call a block. So let's go and have a look over here. We've got this open and closed bracket. All of this code inside is called a block. Down here, all of the code inside these open and closed bracket, we call that a block. All right. And if we go, I don't have any other code. We have blocks sometimes else, other times when we've got while loops, anywhere where we've got an open and closed bracket. But anyway, when we declare a variable, we're able to use that anywhere between where we declared it and the next, closed curly bracket. So this variable x exists within this block. Okay. This variable called answer exists in this block as well. So what that means is if we're down in this add numbers function and we try and use the answer variable, like imagine we just say answer equals 100 or something, there's no such variable that we can access in this block that's called answer. Okay, so let's have a look at this. All right, it's saying undeclared identifier answer. So sometimes people get confused about this. They think, well, I can see a variable called answer that I've declared up here. Why can't I use it in here? That's because these are local variables. So local variables are ones that we've got declared inside a function. So main can access its integer x, its double answer. Inside the add numbers function, it can access its parameters, x and y, and it can access its local variable called sum. All right, so can we access the sum variable up in the main function? No. So if I try and access sum, and print it out or do anything with it really, it's going to say use of undeclared identifier sum. And that's because sum was declared down in add numbers. Okay, hopefully that's clear. So let me go back to my slide. So here's another example. Sum is a local variable. It is declared inside a function. And the local variables are created when the function's called, and they're destroyed when the function returns. And they're not accessible outside the function. And this is a good thing because we don't want other functions accidentally, messing up our variables. We can have our variables nice and contained. It's easier to debug. And our functions interact in a very controlled way just by passing in, arguments and getting return values. But they can't just randomly attack all of our variables. Now, there's another thing called a global variable. And maybe some of you have accidentally done something like this before without realizing it. But let me go back to here. If we just declare a variable like this, I've just got int num equals 10. It's not inside a function. It's not enclosed in curly brackets. It's just out in the wild. This is called a global variable. And the thing about global variables, and this sounds like it's a really good thing, but it's not. This could be used anywhere in this file below it. So down in the main, I'm able to print out num or access num. And that seems great. And down in add numbers, I'm also able to access num. But that's the problem. You've got something that multiple functions can access. And actually, if this is a really big program, we might have lots and lots of functions that could access this value. So it's just problematic. So I could think, okay, this value is 10. Let me just... So I'm writing my main function. I think that value is 10. I go call this function, add numbers, and suddenly it was able to go and change this global variable, and suddenly that variable's changed. And without me looking through all the code for all the places where it might have modified this value, it's going to be very hard for me to track it down. So it seems like it's a good idea, but it's not. It's bad style. It's hard to track down bugs. It also makes it hard, if you've got all your variables as globals, it's hard to keep making up new names. There's a lot of reasons why you wouldn't want to use it. There's a few reasons why you might, but none that we need to do in this course. Okay. So yeah, it's a bit like when you have to, if you've got to leave your food in the fridge, the communal fridge at work, and anyone could go and eat your yogurt or like take a spoonful out of it. It's not a good thing. All right, so they're the global variables up the top. We don't want to use these. Now maybe you've used it like this before, because you might have typed in a variable up the top like this, compiled it, all your code worked and it ran. You might not have even realized that it was any different to putting it in the function. And that's okay if you've done it in the early labs. But now that we're telling you, we want you to make sure you don't have these global variables. Okay, so yeah, the point is you can't access other variables from other functions. Okay, the only sort of interaction we've got is through passing in arguments and getting return values. You can't just generally go and grab things from another function. Okay. All right, so look, it looks like there's a little bit of confusion about all of this. I'm going to do another example now. So the short thing is global variables are not defined in a function. We don't want to use them. The ones that are defined in a function, we do want to use those, but we can't access, like if I'm in add numbers, I can't access the variables that are in the main. And if I'm in the main, I can't access the variables that are in add numbers. They're separate variables. They don't exist in the main if we declared them in add numbers. They don't exist in add numbers if we declared them in the main. Now, let's have a look at this example here. This is an example that typically confuses people when they've just started learning C. So I'll just give you a moment. What does everyone think that this is going to print out if we run this code? And yeah, there's two printfs. What is each one going to print out? So, and somebody asked, how do we know how to break things up into functions? That's a really good question. I guess it's some experience at doing it. You get better at working out when to put something in a function and when not to. So I'm compiling this. Let's see what it gives us. So it prints out an 11, then a 10. Now, what on earth is going on? So this is an example where it's very easy to think, okay, this is called x. I'm passing it into the function. This function is adding 1 to x, and now my value of x is 11. But we've got to remember, this is a local variable for this function. So main has a variable called x, and we've got the value 10 in it. All right, and then we're calling this function increment, and we're just passing in a copy of that value. It's just the value 10 that we're passing in. Now, the increment function, its parameter happens to be called x, but it's not the same variable, okay? It just happens to have the same name, but this could be called anything. All right, so this ends up having a value of 10. So this was the main, this is increment. We're adding 1 to this in increment. It's its local copy. And now the value of this is 11. So inside here, we print out this and it says 11. Now this function finishes. All these variables don't exist anymore that were part of the increment function. And we've still got our original value back in the main, right? So we've just got to remember we're passing in values. Copies, we're not passing in a variable which somebody can change. We're just giving the value and it's going into local variables in the other function. Now, some people are asking, why would you do a function like this? And somebody asked it for the last one. You probably wouldn't do this, right? We're just trying to show you the simplest example. So when I showed you a useful example that really demonstrates why you'd use functions, it gets quite complicated, right? So here, yeah, you could just do increment, but we're just trying to show you the simplest version of a function that demonstrates this particular thing. So when you see a more complicated one, you'll understand how it works. All right. Yeah, now, Ritaj has a very good idea. If we wanted to make this work, we could have a return type. And instead of just updating this to, 11 here, at the end, we could return it. Oops, not return 11, but return x. So we could then be passing back our updated value to the main. But the main would then have to make sure it uses that. It has to go and then update its variable. So the main would get back the 11 and it would go and put it in its variable. So this is how we could do it to make it work. So yeah, that's a good idea. Okay, So, but yeah, definitely when you start out, it does get very tempting to think, have I changed everything? That something like this is going to change this variable back in here, and it's just not. Let me just check I've broken it properly again. Back to the original. Okay, so that's pass by value. All right, so that's sort of the hardest thing at the moment, probably the hardest concept we've kind of learnt. All right, one just small thing before we move on to something else. I said yesterday that if you've got a function that returns a value, you can go and use that function in any situation where a value of that type would be appropriate. And here's some more examples. So if I've got a function that returns an integer, whoops. If I've got a function that returns an integer like maximum does, you know, you've got to think, would it be appropriate to have some integer in this situation? So for example, to give a concrete example, imagine it returns 7. Is it appropriate to check whether 7 is less than 10? Yes. So you can use it in this context. If we had a function that returned a Pokemon, no, we wouldn't be able to put this in this context and compare a Pokemon to 10. But if we've got something returning an integer, we can put it here. If we've got something that's a void function and it's returning nothing, then we don't have anything to compare to 10. So we could not put a void function in here. Hopefully that makes sense. And over here, one more sort of thing, you could also put functions straight into while loops like this and compare what they return in your while loop condition. And this example over here, this is basically my favorite way to do a scanf loop. So, you know, if you're trying to do a loop where you keep trying to read in numbers or integers until the user types in something that's not an integer, this is how I like to do it. So with this scanf%d, we're trying to read in one integer. So if we type in an integer, this will return 1, 1 equals 1. We keep going through the loop. If we don't enter an integer, this will return 0, right? If we type in hello, this will return 0. 0 is not equal to 1. The loop will stop. So this is how you can start writing your while loops if you're not already with scanf. And I've got some code for you to play around with. I won't really go through it now, but you can have a look if you're interested. There's 3 different ways to do a scanf loop like that. But that first way is my favorite. So you can go have a look at that in case you ever need to do a scanf loop where you keep reading in something. Okay, any questions before we go? I think they've been, yeah, I think the questions are all right now. Okay, we'll be doing functions, you know, forever now. We're always going to want to put our code in functions, so it's not the last time we see functions. Let's talk about style. So someone's talking about, yeah, we will look at for loops today, but let's talk about style. So when we're writing C code, the computer does not even understand C code, right? We use DCC, it compiles that code, and it then spits out noughts and ones into our executable, and that's what the computer understands. The actual C code, that's for human eyes, and that's for us so we can understand it. It's for our colleagues to understand, or in the case of, you know, if you're a student, for your tutors to understand. So we want to make it easier to read for us and our tutors. Now, when you work at different organizations, so I should start this by saying, you know, every term people look at our style guide, because we've got a style guide. Let's open it. We can have a bit more of a look, but we've got a style guide. Every term people look at it and say, oh, I don't like it. I don't like doing this like this. I saw that somebody else does this like this. I didn't want to use 4 spaces for my indentation, etc. And that's fair enough. We get into habits and we want to do things the way we like it. But if you ever go into programming, any organization that you work for or anywhere you study as well, they'll have their own style guide, and there will be like minor differences. There'll be a whole lot of basics that you'd see in any style guide, but there might be individual slight differences. So you've got to get used to following the style guide of your organization. So we've got a style guide that we think encourages you to get into good coding practices. So we want you to follow it. Now, what are the benefits of doing this? Well, if you write with good style, there's less possibilities for mistakes because your code's easier to read. And it's easier to debug. So overall, it'll help you code faster, right? That's the real reason. Now, in terms of, why would you do it for this course? Well, in assignments, you'll get marks for style. So the assignment that's coming out next week, I think is around 20% style marks. And the assignment will really give you the details of what we're expecting for that style when it comes out. There'll be a rubric. The other reason is, so to get marks, yes, in your assignments, also in the final exam. So in the final exam, this a bit like a maths test, right? You might, do you do maths tests still where you're writing out the answers, and maybe if you don't get it right, they'll still check through your working to see what marks to give you. We do the same when we're marking your code. I mean, it's not handwritten, but we'll go and read your solution because maybe your solution doesn't 100% work, but we'll go through and look and see what marks it deserves. Now, it's going to be hard for us to do that if your style's really, really, really bad and you've called your variables A, B, C, D, E, F, G. We might not realize that you've actually done something really good in there. Just like when I used to do my maths exams, I would just scribble. It would be so horrific. Yeah, it would have been very hard for them to mark it. All right, so what things are we trying to do? Actually, to give you a bit of an example, I'll show you an example of really bad style, because that really can show us, why we might really want to do good style and what things are really bad. Now, does this look like bad style? I'm good. I'm seeing a few yeses, which is good. Now for me, you will all have different ideas, but for me, the thing I dislike the most is I found it hard to even find the main. So sometimes a bit of vertical space helps readability. Now I can at least see where the main starts, and our main should have a void there. So there's so much wrong with this, right? So I've just done that one thing, and I think there's lots of problems with this indentation, but I just want to at least put it in there so I can see very clearly now that this is our main function. There's still a lot to be fixed up though. So on line 10, we'll just do a few examples. We can't fix the whole thing. We'll be here all day. What's wrong with line 10? Yeah, it even hurts your kidneys. What's wrong with line 10? Well, this should be capitals, right, for a hash define. And even here, I might want a bit of white space, like one line between my hash includes and my hash defines. This looks okay, but what on earth is O_S? I've read through this before. I still am not sure what this O_S means. So we want to make sure that our names are good enough that somebody can work out what they're talking about. Like budget, sure, that is meaningful. O_S, I'm still not sure what it means. Now with our structs, Again, and you can go and look up the style guide. Actually, let me flick over to the style guide. Now, with the style guide, it tells you all about so many things, code layout, indentation, for example. And a lot of the things sort of tell you the rule, and then you can get a more detailed explanation. You can get an example of good indentation, and then an example of bad indentation. So there's a whole heap of information. If there's anything you're not sure of, you can look it up in here. But just looking through here, yeah, you'd want our structs like this, etc. Okay. All right, I won't go through the whole thing. You can see, you can try and fix it up and see what the style checker thinks. I think the style checker will have a lot. I think I'm in the wrong directory. Oops, 1511 style. Yeah, it's got a lot to say. There's a lot wrong. Now, one thing I want you to just be very careful about, right? When you're fixing style up, just be careful that it still compiles, right? Because in this example, I went and changed this hash define to make the style better, but it broke something because somewhere in the code, you know, it was using the budget that wasn't all capitalized. So after you've ever fixed style, just check it still works. Some people finish their whole assignment, then at the end, go and fix the style, submit it, and it doesn't work. And maybe it's 2 seconds before it's due or something. So just check it after you've fixed any style things. Okay. Also keep in mind 1511 style won't find everything. I don't think it finds global variables. You still have to have some awareness of what you want to do. And a really good tip is you can always ask your tutor for feedback about your style. Ask them in a lab, what, you know, do you have any recommendations for my style? Ask them, you know, when you're partway through your assignment. That's certainly fine. The other tip is, yeah, don't fix your style at the end. The good style will help you write your program. Don't write 1,000 lines of code, then fix the style. Also, don't write 1,000 lines of code, and this is unrelated, but don't write 1,000 lines of code and then compile it. You should be compiling and running your code along the way as soon as you can, not writing, you know, lots and lots of lines. Okay, get on top of any little errors sooner rather than later. Okay, so that's style. And yeah, all right. Oh, we will have a break, but not just yet. Okay, let's show you some handy code, handy new syntax for C. Actually, some people were asking about this. So in C, now you don't need to write any of these new things I'm showing you. They're just nice. They can save you typing. So I really love them. So instead of writing count equals count plus 1, because this is such a common thing to do in loops, you're often writing something like this, you can just write count plus plus. It does the same thing. It increments the counter by 1. And there's also a count minus minus, which decrements it or subtracts 1. Now, if you're trying to add something that's not 1, like you're trying to add, say, 5 onto a variable, you can use this syntax, plus equals. So writing count plus equals 5 is the same as count equals count plus 5. And there's also one for subtraction. All right. So don't use them if you don't want to. Do at this point what you remember and what's, you know, convenient for you, but you might see them. Okay. And I'll probably throw in a few today later in the second half. Maybe I've already done this before without realizing it. Okay, now there's another type of loop. So we've shown you while loops, but there's something called a for loop. And in C, for loops are really just the same thing as while loops. For loops can't really do anything different than a while loop. It's just a slightly different way of typing it in. And they're very handy for when you know the number of iterations. So like when you've got a counting loop with a counter. But you can still write all the code you ever want to with while loops and never use a for loop. So this is what a for loop looks like. So, well, you've got the word for instead of while. And you've still got a condition just like a while. But all in this one area, you've got everything that controls the loop. So you've got your initialization, and then you've got your increment. Now, even though it's all sitting here right at the top, this only gets done once before the loop starts. This gets done every time, just like in a while loop. This also gets done every time at the end. So it looks like it's all happening here at the start, but this is identical, well, almost identical to a while loop. So let's compare. We've got the while loop over here. The for loop, it works exactly the same way, but we just stick this in here. Then we've got our I is less than 10. We've got that in here too. We've got our I++. We've got that in there too. It's all being executed at the same time as it would in the while loop. We're just writing it here differently. Now, why is it nice to do a for loop? Because I think it's confusing at first. It's easier to understand the while loop. But once you get your head around it, it's nice because I can see all in just one spot, everything that controls the loop, and I'm less likely to forget to do my increment. So sometimes I forget to do my I++ when I do a while loop. It's much harder to forget that with a for loop when you've got it all here. Sometimes I forget to reinitialize my counter in a nested loop. It's harder to forget when you've got a for loop. But this is up to you. If this is something you want to get into using, you can. You don't have to. Okay. All right, and I'll try and show you some for loops today and some pluses in the code we write. All right, so I'm going to start this topic and just do a very basic intro, then we'll have a break. But yeah, arrays, it's a really important topic, and it's very powerful to be able to use arrays, as we'll see. Okay, so why would we use arrays? Well, what if you wanted to store many related values of the same type? So here's an example, and look, this is only 7 values, right? So imagine I had the important task of tracking the number of chocolates I'd eaten in a week, and I had 7 different variables, one for each day of the week, and I kept track of how many chocolates I'd eaten. I don't really eat this many chocolates, I promise you. Anyway, so this is only a week. You know, imagine if I did it for 365 days. But anyway, even with a week, I've got 7 variables. They're all integers. I've got 7 of them. It's quite annoying because just say I wanted to do something like find all the days where I ate more than 3 chocolates, like 3 or more chocolates. I then have to go and do this if statement 7 times. I have to check, well, did I eat more than like 3 or more on day 1? Did I eat 3 or more on day 2? I'm going to end up not with just 7 variables, but a lot of duplicated code, you know, interacting with those variables. So does everyone agree? No shame in eating a lot of chocolate. No, but I really don't. I would love to eat that much chocolate though. Does this seem repetitive? Hopefully everyone thinks this would be repetitive. What if I was tracking a year's worth and I've got 365 variables? I've got 365 if statements, checking if I had 3 or more on those particular days. Okay, now, you know, what can we do about this? Well, in computing, we have things called data structures, and data structures are ways to organize and store data so you can access it and use it efficiently. So in this course, we're going to learn about 2 very important data structures. So now we're learning about arrays. After the flex week in week 7, we'll be learning about linked lists. And these are our 2 sort of hurdles for this course. So arrays are a hurdle for everyone, and that's what we're doing now. So it's a data structure. Now, you'll learn about lots of other data structures if you go on and do more computing. I think you'll do a whole course called data structures and algorithms or something. And there's no right data structure. It's not like we're showing you data structures that are easier, but there's ones that are better, but they're harder. These are data structures that you'll use forever. There are other ones, they're all different and they all work better in different situations, okay? Depending on what you're trying to do. But you will see arrays like in anything you do in computing. Okay, so what is an array? So an array is a collection of variables all of the same type, which we can call homogeneous. And this is very different to a struct, right? So with an array, you might have an array of integers and you're storing a whole collection of integers. They all have to be integers. You can't have one int and then a char, then a double, then an enum Pokemon type and a struct Pokemon. They all have to be the same type. So that's very different to a struct. It's contiguous. We've got all these big words today. Contiguous. So all the data is stored in consecutive memory locations, just packed in right next to each other, which is important when we see later how we access it. It's a random access data structure. So what that means is if you're storing hundreds of pieces of data, you don't have to sort of traverse or go through all the data to find the one you're interested in. You can just jump to the one you're interested in, and it's no slower than jumping to, you know, the first one in the array. And it's an index structure. So if we're storing hundreds of things, we just need one variable. It's not like a struct where we have one struct variable, but all the parts in it still have a name. We've got one name for our array, and then we just use indexes to go to the array at different sort of locations to access the specific pieces. All right, yeah, and an enum, when we create an enum variable, that can just store one value, right? An enum, any variable of type enum stores one, basically an int or a numeric value. When we design the enum, we're giving a set of possible values for it, but we can't store we're not storing more than one value at a time in our enum variables. All right, so that's a bit about arrays. We're going to have a quick break and we'll come back and get into coding of the arrays, or of some arrays. All right, let's come back at about 5 past. Okay, welcome back from the break. Okay, so we're going to really go into talking about arrays. So, you know, and why would we want to use arrays? Well, this example here, we've got all these variables for the number of chocolates eaten. All right, that's not so useful, but I don't want to keep giving examples that scare you, but we might need something to store, you know, 1,000 marks. 1,000 final exam marks, right? And we don't want to have 1,000 individual variables. So we could have an array storing all of the different marks. All right. So, you know, there's lots of situations where we've got a huge data set and we could store that in an array. And then if we know how to use the array, we can go and, you know, get the sum of the data, the average of the data, find things in the data, whatever it is. And we need to, psychological fear tactics, and we need to be able to do that in an efficient way in terms of, you know, how much effort is it for us to write this code and read it, but also in a way where it, you know, runs well. Anyway, let's go and have a look at how we do arrays. So in this example of the chocolates eaten, I would declare it like this. So this is like, you know, when we declare a type int x, you know, int is the type, x is the variable name. Well, here the variable name is chocolates eaten. This part here is telling us it's an array. These square brackets with a size in it is saying it's an array of size 7. So, and what type is it? It's an integer array. So we can only ever store one type in an array. This is going to be an array of integers, and it can store 7 integers. All right, that's the maximum size we've given it. Okay. Okay, now what could we do with it? Like right now when we've done this, I've got an array, and often we visualize an array like this. If it's size 7, you know, there's locations for 7 integers, but right now I've just gone and asked for a chunk of memory. It's all uninitialized. Okay, now how can we initialize it with some data? Yeah, look, sometimes you might make the array bigger than you need it to be and sort of keep track of how many things you've put in it. But for now, let's assume we're, like, how do we just initialize an array? Imagine if we already know the data in advance, we can initialize it like this all at once when we start off. We ask for an array of size 7, and we can put all of these values in straight away. That's one way to do it. We saw the other way where we don't put values in, we just leave it uninitialized. And this is a nice way of initializing everything to naught. It looks a bit weird because it doesn't look like we're initializing anything to naught. But once you use these, in this context, these open brackets and like these curly brackets, in this context, it's an initializer for the array. As soon as you use this, it'll put the values that you specify into the array, and for all the other values, it'll just set them to 0. Okay, so right now, everything will just be set to 0. Whereas if we had given like a couple of numbers, the first 2 would be set to 3 and 5, then the rest would be set to 0. Anyway, those small details aren't that important. Now, and one more small detail, if you're going to use this kind of initializer for an array, you have to do it on the same line when you declare it. You can't declare your array and then later on do this. But again, that's sort of a minor detail. So let's get to the more important parts. Now, this is how we would often visualize it. And typically once we're doing array stuff, we often do want to draw it. Think about you know, what's happening before we just jump in and code it. So if I've got an array of size 7, I would think of it like this picture down here, right? And we've got all these values in here: 4, 2, 5, 2, 0, 3, 1. It's all initialized and packed in. Remember, we used that word contiguous. They're all right next to each other, all these little places where we can store ints. And they've got indexes. So what we need to just get used to is the fact the first index will be a 0. Okay, that sort of trips people up. So if I've got an array of size 7, I'll have indexes 0, 1, 2, 3, 4, 5, and 6, but I will not have anything at array 7, right? My indexes will go from 0 up to 6. You know, if I've got an array of size 100, I'll have indexes from 0 to 99. And at every single index in this array, they're all storing an int. All right? Now, how can we access these individual integers? Well, we use the indexes, and we do something like this. So if I say chocolates eaten, and I put these brackets and say at index 2, that's going to go to index 2 and get the value out, which in this case is 5. Okay, and for example, if I tried to get the one out of index 5, well, no, if I went to get the one out of index 6, it'd be the value 1, right? Now, what if I did try and go to chocolates eaten at index 7? So I go to here, so I'm trying to think that there's an index 7. There is no such thing. I'm going to get some kind of error. And depending on what compiler we use will depend on the error we get. But with DCC, it'll give us a runtime error saying, it might even pick it up at compile time. It might say, hang on, why are you accessing index 7? If you've hard-coded the value in, it might say that. Or it might not realize until runtime. And then it might say, and I'll show you in a minute, out of bounds, or you've gone past the end of the array, something like that. Now with other compilers, it might not do that. There might be some other variable that's stored in here that has completely different information, and it might just go and give you back that data. Like there might be a variable there saying, you know, how old your grandmother is. It might go and get that if that happens to be in that location in memory. Or it might go and try and access a piece of memory that it's not allowed to, and the whole program might crash, and it might say segmentation fault or something like that. So it's actually much better that DCC tells us straight away and we know what's going on, rather than getting weird garbage values or just getting an error that says segmentation fault and doesn't really tell us any more information. But anyway, whatever you do, it's going to cause a problem. All right, just a few other things about arrays. You can't print a whole array, like typically, except for one special type of array that we'll talk about next week. But you can't just printf a whole array. There's no %a to print a whole array of integers or something. You've got to go through and print all the individual elements. And you can't scanf a whole array in either. You've got to scan in individual elements. You also can't, and this is where it differs from probably everything we've seen so far, you can't just assign a whole array to another array variable. So if I've got int x equals 5, I can say something like int y equals x. We're allowed to do that. We can do that with structs as well. We can't do it with arrays. This is not going to compile. I would have to manually create this array and then go copy in each piece, you know, one by one. And that's just something you'll get used to. All right, so there's no printf that just prints out my whole array for me. So do we think this would be a good way of doing it? Yes or no? And if not, how could we do it differently? I'm glad people are saying no. While loop, yeah. So this is repetitive. This would work, but imagine we are processing 1,000 student marks. We don't want to do it like this. Even for 7, it's bad. But yeah, we can use a loop. So if we notice, often when we're dealing with an array, we might go through it one by one, right? If we're printing the whole thing out. And in that case, we're going through each index. We need to go to the one at index 0, index 1, index 2, index 3, index 4, index 5, index 6. So it's very easy to write a loop that can generate these numbers, right? We all know how to do that loop, or we've all sort of seen a way you could do that loop. But now when we generate those numbers, we use them for our index into our array. Yep, that looks, I can see somebody's written sort of the code for it. So let's have a look. But basically, this loop is just generating values of I that go from 0 up to 6, but stop. I is going to stop before it actually gets to 7, which is good because there's no index 7. But then we use those values of I to get, access the individual integers in our array. And I've even done an I++, right? It just means I equals I plus 1. Now, some of you might be thinking, I is a bad name. We've just been talking about style. I is a terrible name. And it seems like maybe it is, but in computing, I is just so well known as being used as a counter in a while loop, especially if we're accessing an array. Like you can think of it as the index or something. So in this context, because it's so widely used and known in computing, that I is meaningful. It looks like a loop counter. It looks like an index for a loop count, like a index that you're going to increment in your loop. So it's okay to use I in your loop like this. Okay. The 7, not so great. In my real program, we'll have a hash define. So what's going on here? I'm just trying to print out the values in this array. I've got my while loop. Let's go through it. I starts at 0 and we'll end up printing out chocolates eaten at index 0. So it'd print out the 4. Then when we add 1 to I, we're going to end up printing the 1 at index 1. So we'd print out this element. And then each time we increment I and we use it as an index, we get the next one, and then the next one, and then the next one, and then the next one. And we keep incrementing our index. And we get to 6, we print that one out. Now at some point, I will get to the variable I gets to 7. This is no longer true and the loop ends. Okay? And this is how we can go through the whole array from beginning to end. And we often call this traversing an array. And you'll often do this, whether you're going through printing it out, reading data into it, calculating the sum of all the values. You will often start at the beginning and go to the end. And it's always going to look like this, like a pattern like this. And yeah, you could write this as a for loop. Okay. So let's go play around with these things in code. So yeah, here I've got my hash defined days in week is 7. Okay, it makes it much clearer that we're talking about, you know, days in a week, and that's why it's 7 rather than just a random 7. So again, just a reminder, it's always good to draw these things. So I've got my chocolate eating and I've got these values inside it. And I've got those indexes. Now, how are we going to, if we wanted to just print the element, whoops, at index 1, how am I going to do it? Well, every element in this just happens to be an integer. They're all integers, so we would use %d, and the name of the array is chocolate eating. It should be eaten. Let's change it. Doesn't really matter, but let's change it. But then we've got to give it the index. It can't just print out the whole array. We've got to say, in this case, we want the one at index 1. And what value is it going to print if we do the one at index 1? Yeah, the 2. Let's just check. Yeah, it printed the 2, right? But yeah, it's very common to forget and think, hang on, the one at index 1 is this first one. No, that's the one at index 0. Now I told you that if it was size 7, there'd be nothing at index 7. But what would happen if we just tried to do it anyway? And I did kind of say what would happen, but let's just see it, because you'll probably do it at some point. I'll get rid of my picture for a minute. Now, DCC is trying to warn us. We've hard-coded the value 7 and it realizes no, there is no 7th element. Just say we don't listen to DCC for some strange reason. We think we know better. And we run this. Yeah, it's going to crash and you're going to get this thing saying runtime error, index 7 out of bounds for type int 7. So it's not going to go and let you just get out some random value from the variable next door. So let's comment that out because we don't want our program to keep crashing. Now imagine I wanted to just get the first element in the array and the last one and add them together. How would I do that? So the first one would be at chocolate eaten at index something. And the last one would be chocolate eaten at some other index. Yeah, the first one would be at index 0. The first one in an array is always at index 0. Now in this situation, the last index of the array is 6. But more generally, the last index in an array is whatever the size of the array is minus 1. So sometimes it's nice to do it programmatically, like days in week minus 1. Then it's quite clear that it's, well, if you spell it correctly. So sometimes you've got the size, and by going to the index at size minus 1, you get the last one. I mean, both of these are going to work. I just want to point out some of the patterns that exist. Now, I haven't used this variable. So when we run it now, hopefully it prints out that the sum is 5. Yep, it does. Now the next one, I want to go and modify the middle element and make it 99. So in this example, you know, which one is the middle element? I think it's here at index 3. Oops. So to modify something, again, I would just, like you would modify any integer variable, you would get the integer variable. So this is at index 3, the middle one. And you just go, that particular integer equals 99. Oops. Now, is there any, yeah, and somebody's written in there, we could also write this as days of week divided by 2. Days in week divided by 2. And this should work for any array. Doing days in week divided by 2 will give you the middle element, if there is one middle element, which in this case there is. So 7 divided by 2 with integers gives us index 3. That gives us this middle element. And then, you know, if we had an even number of these things, it would give us one of the middle elements, right? And then you might care about, like, imagine you don't have this element at the end. Well, now which one's the middle? You know, some people might say this one is, some people might say this one is. And then you might have to sort of think more about it. But in general, you get one of those middles by just dividing by 2. And yeah, you can do tricks to get the leftmost one, jelly bean. Okay, but for today, let's just do this one. So now we should have modified one of those values to be 99. All right, so now how can I print out all of the data? Well, we can do that while loop that we looked at before. So remember, we want some kind of counter that starts at index 0, because that's where our arrays start. I'll just clear this. And we want it to go up to the end. Now, what's going to happen if I do something like this, less than or equal to days in week? Yeah, you'd get an out of bounds error. So you might accidentally do that. All right, but other than that, we would do a printf. We'd do printf%d. Let's just do a space after it. And we do chocolate eaten at that index I. So it's exactly kind of what we just saw on the slide. And then we've got to make sure we increment it. So this should go through one by one from index 0 up to index 6 and print out each element. Yay, and maybe I could have put a printf at the end with a new line. Yeah, otherwise I'd get an infinite loop. Now, yeah, somebody said it's long and tedious to divide by 2. Yeah, it is in this situation. If we were writing some kind of function that always wanted to be able to get the middle value though, maybe it would be able to take the sort of size of the array and always get the middle value back by doing it like that for different arrays. So it's sometimes interesting or helpful to see the general pattern with the indexes, yeah. But in this case, yeah, we could have just done that. All right. Now, oops. Hopefully, like, these are the basics. Let's go and write a few more things. So we already know how to print the array. Okay, so I'm going to copy and paste this code, except in here I've got a completely different array name. So I'm going to change that. My array is called numbers. And that array has a completely different size. But other than that, it's the same. This is still an array of integers and the logic is still the same. Now, can anyone see any issues with me compiling and running this code so far? Let me just try it. So what does this array have in it at the moment? Yeah, it's not initialized. So if we try and print it out right now, it's going to crash and say this data is not initialized. What we've asked for is an array big enough to store 6 integers. Okay. So there'd be indexes from 0 up to 5, but they're all just uninitialized right now. So it's not a good idea to print them out. But this time, instead of hard coding values, let's read them in from a user. Right? So maybe I'll just remind the user what to do. Oh dear. And now we want to scan numbers into the array. Now this is going to be the exact same logic as the printf. Instead of printing out one element at a time, starting at the first index and ending at, the last one and going up one by one, instead of doing a printf, we're basically just doing a scanf at each point. So we've got the same logic. We're traversing our array, starting at index 0, going up to the last index, but now we're doing a scanf. And it's an integer array, so we're going to use a %d. And it's still going to be numbers I at each point, but we're doing scanf, so we've got to put this ampersand, because it's basically reading in an integer. So this should allow us to read some data in now, rather than hard coding it. Now you can't declare the same variable twice. You can reuse it and set it back to 0. So that's better. So now we're entering 6 integers. I don't want the same. How many have I done? I think one more. Yay, and then we print them all out. Very exciting. But that's how we can actually get some data in there from the user. Any questions so far? Now, just say we wanted to just sum all the elements. Like we want to process this data. We want to go through and sum it. Maybe we want to find the average of it. Who knows? Yeah, we could add it and print it at the same time, but we've just printed it. Let's just do it again just to see if we were just adding it, how we would do it. So if I want to do the sum, again, I'm going to use the same principle. I'm going to start at index 0. I'm going to go through and I'm going to get each value out one by one, and I'm going to add it to my sum. So basically, I just use this same structure again. I'm still traversing it. I'm going from the first index to the end. Now I'm going to need some sort of counter. Okay. And each time I'm just going to add on the next value. So if I typed in 3 minus 1, 5, 99, 8, 2, we're going to go along and we're going to add 3 onto the sum. Then we're going to add the minus 1, which gives us 2. Then we're going to add the 5, which gives us 7. Then we're going to add the 99 and so on. So we do numbers at index I and we add it on. Now, not everything you do with arrays, I should use this. I've calculated the sum, but we need to be able to print it out. Now, not everything you do with arrays is going to follow this pattern where you just traverse it from beginning to end, but there are lots of occasions when you do that, or maybe you do that but you've got some if statements in there. So it's something to get used to. Enter 6 I can't even speak anymore. Integers. 1, 2, 3, 4, 5, 6. Oh, what have I done wrong? I got a sum of 1. That is incorrect. Yeah, plus equals. I said sum equals numbers I instead of sum equals sum plus numbers I. That should fix that. Is that correct? And yeah, we could have used plus equals. Is this correct? Yes, I think so. One more, I'll just do this very quickly. If I wanted to increment all the values in this array by 10, again, we use the same pattern. We will do things that don't use this pattern, but for the first day, I just wanted to show you how many things you could do just by knowing how to do one of these while loops that goes through the array. Now you might think, why would you want to go through a whole array of numbers and just change them all by a constant factor? Well, maybe you're, increasing the prices of something, scaling everybody up by uniform amount if they're marks. If it's a graphics thing, you might be moving all of the points across the screen. But here we're going through every single element in the array from start to end. Whoops. And we're adding on 10. And at the end, we'll print the array again. Okay, so we got the sum, we added 10 onto all of them, and everything we did today, not forever though, all use this same pattern. Yeah, I'm actually modifying the array. I was going through one by one, starting here, and I was actually adding 1 onto it, so that gave me 13. Then 9, etc. We're going through and modifying them all one by one. Okay. Now, we're not going to have time to do it today, but we want to start looking at how we can put these in functions, right? Because we might have noticed every time we printed the array, I copied and pasted this same thing. And we certainly don't want to do that. We want to be able to have functions that can print a whole array. you know, find the sum in an array, all those sorts of things. We probably won't do it today because we're running out of time. Yeah, I could go out, but yeah, let's do this. I could go and print every second thing in the array if I wanted to. But you can't change the indexes. But I could go and print every second. Oh, I've got to go and enter all the data. Right, I could go and just print every second one. Keep in mind I've added 10 to it. So I'm printing this, skipping to the next one, skipping to the next one. But no, Ritaj, I realize you can't change the actual indexes. It's always going to go from 0 up because they're actually sort of offsets of where they're, you know, living within the array. Okay, so that's sort of the basics. Why isn't it printing a new line? Yeah, it did. There's a new line there. So yeah, we won't go into arrays and functions. I think we've done enough for one day in that respect. We'll learn how to do those on Monday in the pre-recorded video. And we'll also look at two-dimensional arrays. So, and also we haven't finished yet, so don't get too excited. Before we do functions with arrays, let's just make sure we're on top of functions in general. So we'll do a quick functions Kahoot, see how we're going for time. So anyone who wants to join this Kahoot, someone's asking why we need a while loop for scanf. If you're trying to read in many values to put in your array, you've got to read them all in with a scanf. So that's why we've got it in a loop. So each time the scanf is reading one thing in, but we wanted to read in 6 or 7 values, so we had it in a loop. I'll just wait another minute or so. Okay, maybe we'll get started because I think we've tapered off. Okay, yeah, let's get started. And don't forget to come and get your chocolates in face-to-face if you win chocolates and or Skittles. And yes, Fishy J, yes, that's correct. Yeah, all of the above. So functions help us to do all those things, reduce the amount of like duplicated code, group together related instructions. So all the instructions that you want to, you know, print out your Pokemon, they're all grouped together. They can compute a result and return it to the caller, all of those things. Okay, next question. very good. Had a lot of words in this one, didn't it? But yeah, that's correct. It's the declaration of the function. So it's the function's name, the inputs, and then the return type. Okay. So yeah, this is a trick question, I think. We can use the functions we write ourselves, and we don't need to import a library to do that. So no, we don't actually need to import a library to use functions in C. We do need to import libraries to use library functions in C. Yeah, it's a very trick question. Okay, so when we're actually calling a function, so down here, this is basically what a function prototype looks like, the green one. Okay, with the inputs and the outputs and the types. When you're actually using the function, you're just passing in your values or your variables. Okay. So that's what you do. You don't put the types in there. Does that make sense? Okay. Okay, excellent. Oops. So with this one, up in here, this is where we do put the types, right? So whatever inputs we have, and we're working out, well, if we put A in here, this must be an int, and this one's probably a double, right? So that's out of these possibilities. This is going to be an int with some variable name. Doesn't have to be A. And this is going to be a double with some variable name. All right, we don't just put in the variables up here. This has the full type. And it wouldn't be void because we're passing in information. What was the other alternative? Yeah, and there's no structs in this. Okay. All right, 67. Now I've got to warn you, this is a very tricky and cruel question. Well, not very tricky and cruel, but a bit tricky. Okay, now, as reasonable human beings, you might think that this is just going to give 10, right? So, you know, you'd be forgiven for thinking it was going to, you know, 3 plus 7 equals 10. But in here, we've got result equals 0. And we're passing in 3 and 7. And in here we have a result, it's equal to 10. But we never assigned it back to here. So our result back in the main is still equal to 0. Does that make sense? So we would have to say result equals sum for this sum in the main to change. Yes, so this was tricky with a ticking clock. So it's updated the result variable in the sum function, but not down here. And it returned the value, but we forgot to assign it to our variable. And these are all common mistakes, actually. But if you made that mistake, you'd be more aware because you'd see the printout and you'd at least know that there was a problem. Okay, so well done if you worked that one out and noticed that with that, you know, 30 seconds or whatever it is. This is another kind of cruel one too. So another sneaky one where, you know, you're going to think, well, we're passing in 5 and 6 and it's multiplying things, so we're going to get, you know, 30. But there's this sneaky thing here where we've passed in 5 and 6, but then we go and say, well, x is equal to 4, and we end up doing 4 times 6, not 5 times 6. Now, you know, it's very sneaky in this context where we don't have any meaning in our variables, right? We end up printing out 24. So I would say the style in this code has probably led people to get it wrong, but there we go. Technically, this is what you'd get. So today's had a lot of sneaky questions, I think. Hang on, what am I doing? So let's see who. Innovative Bonobo, Polite Bison, and Remarkable Crane, well done. And Capital and Amiable, I didn't see the whole name. Well done to you too. Well done to everybody. Hope you don't feel too ripped off by these sneaky questions. Come and get chocolates the next time we have a face-to-face lecture if you know, came in the top 5. Yeah, Jellybean, you can get the screenshot of that or whatever and come and get chocolates. We're not there next week on Monday though, but the next time. All right, so we'll come back, we'll finish off the arrays and functions in the next lecture. And in the next lecture, which is going to be the recording, we're going to look at 2D arrays, like where you can store things like, you know, matrices or tables or boards, like in a board game, and also strings. So we'll be able to store like people's names and text. And we also get assignment 1 next week. So the material we covered today and that we cover on Monday will be very, very important for that assignment. Okay, that's it. I hope you're all having something nice for dinner tonight. And I hope you have a nice long weekend as well. All right. Reach out to the forum, to the course website, and all the usual places if you've got questions. Thanks, everybody. Thanks for all the great questions and for participating in the Kahoot, and see you later. Yeah, so Monday will be a pre-recorded thing, but it will be in that. Yeah, for sure. Okay. Thanks, everybody. Bye.